Hi, my name is Sanaya, and today I'm doing my final project for Intro to Material Science on simple cubic structures. So lattice structures and crystalline solids are often used in real life by researchers and scientists and engineers, but the structures of them is what is the determining factor for things. But a structure of a solid is best described by the unit cell, in which is the simplest repeating unit. So lattice structures and crystalline solids can be used to help metals, but it's basically used to help the physical properties of a part and to shape them. But lattice points represent the location of the atoms or ions, and as you can see here, there are 8 lattice points, and those are 8 corners. Basically the same thing. But the structure consists of unit cells repeating in 3 dimensions, which we can kind of conclude because it speaks about spheres. But in simple cubic structures, there are spheres in one layer that are directly above or below the ones in another layer. So they're basically surrounded by another sphere. The spheres aren't actually packed very tightly, which is what makes simple cubic structures special. And their atomic packing factor is around 52%. But that means that the volume of the container can only be filled 52%. Each atom only contacts the nearest atom or neighbors in that layer or plane, and that can also be described as a coordination number, and each structure has a coordination number. For simple cubic structures, that number is 6. I really liked researching this topic and talking about the simple cubic structures because they are so rare, and I like rare things, but they are rare due to their low packing density, and there actually is only one element that is deemed a simple cubic structure, and that's called polonium. And that is also a metal, and it is highly radioactive and toxic, so anyone that's using that or surrounded by that element should take a lot of precaution. It is also very rare, and it's highly volatile. I added some pictures here of it. I think it looks so pretty. All of the atoms basically have sphere volumes added all together in a unit cell that is deemed as the atomic packing factor, which was the 52%, but it basically means the volume of atoms over the volume of a unit cell, and one atom at each of its 8 corners is contained by 8 unit cells, which we saw at the lattice points in the previous slide, but 1/8 of the atom is filled in each specific unit cell. The atomic packing factor has a lot of math, well, just a little, but it basically means 8/8, which is also 1 times 4/3 pi r cubed, and that's the volume of the atoms. But the atomic packing factor a little bit more in detail. This is the formula that you will use. So the atoms per unit cell is going to be 1, and the volume per atom is deemed as 4/3 pi a half a cubed, and that's divided by the volume per unit cell, which is a cubed. But because a simple cubic cell is cubic, it has 3 lattice parameters, A, B, and C, and those help define the size of the unit cell. For a simple cubic structure, that's going to be 2R. This is my physical structure. I went back to kindergarten and used Play-Doh because I wanted to play with Play-Doh and I didn't want to just do something on the computer. I wanted to get a little bit creative, but I basically just rolled the Play-Doh up into different balls, 8 to represent the 8 lattice points or 8 corners of a simple cubic structure, and then I put it together with Q-tips, well, toothpicks. So yeah, that is my project.